All right, let's talk about binomial random variables. But before we do that, let's just see what I'm talking about. We have a lot of notation, a lot of definitions here. But let's see exactly what's happening. So let's look at this example where our free thrower is still making 62% of her baskets. We're still assuming each shot is independent of the last. If she shoots 10 free throws, it turns out that this is the probability distribution of how many she makes. Very unlikely that she doesn't make any. Very unlikely she makes all 10. But you can see that it becomes more likely that she gets 6 or 7. This makes sense, right? If you're making 62% and you're shooting 10, we would expect you to make about 6. And we can also visualize that with a histogram. Okay, how many she's making? The likelihood is how tall each box is. So again, we can see that 6 baskets is what we would expect, and it's slightly skewed to the left. Okay, it's unimodal, and we're going to recognize this when we do more binomial distributions, and we can see how likely each event is. So, what is binomial distribution actually? So in the last section, we talked about finding the probability that the first success is after n trials, or again, n attempts. Here, we still have Bernoulli trials, those definitions from before, but we're interested now in the total number of successes. So instead of, okay, what's the probability of the first success being after 10 attempts? We're going to say, what's the probability that after 10 attempts, she makes a certain number of them? And this is a special distribution called a binomial distribution. So distribution, again, where does the randomness go? What are the outcomes? What are their probabilities? That's what distribution means. Binomial is a special kind of randomness that follows a few rules. So this is how we write it. X is our random variable. And this right here, this tilde, means distributed. So when we write it like this, X is distributed as a binomial distribution with parameters n and p. That's what that means. P, remember, was the probability of success. N, oh, do I not tell you that anywhere? Oh yeah, N is the number of trials. And X is just how many successes do we get in those n attempts. Q is the probability of failure. It's just not P. So, again, expected value, standard deviation, we still have those same formulas as before. Remember the standard deviation formula. You remember the standard deviation formula? You don't have to write this down. But the standard deviation was the square root of the variance, which meant we add up all the x minus mu squareds, multiplied them by their probabilities. You can still do that here. But it turns out the standard deviation, if we have these special things happening, we have Bernoulli trials and we want to know how many successes we get. The standard deviation gets a heck of a lot easier to calculate in this special case. This works for every random variable. This works for the special case of binomial. Binomial being those Bernoulli trials, those 3 requirements, independent, same probabilities, and oh my gosh, I'm getting over a sickness right now. I've really got sick brain. And only 2 possible outcomes. Okay. So we have nice shortcuts. We'll also model this on the probability page of GeoGebra. Here's what that looks like. And again, I recommend that you either pull it up on Canvas or click on it if you do have the PDF. If you have it printed out, clicking won't do anything. Yeah, you can pull it up on Canvas. Let's go to this probability page together. Okay, so pause the video if you need to, because it's really important for you to be following along right here. I need to find out where mine is. Here it is. Okay. And when you pull up the probability page on GeoGebra, this is what you're going to get. Okay. You're going to get a normal distribution, a bell curve. We're not there yet. We want a binomial distribution. So we're going to go down here and click and say, no, I don't want normal, don't want student, don't want chi-square. These are all these special distributions. There's so many special distributions. You want to scroll down to the second half. The first half were all continuous. The second half is all discrete. And we'll have a binomial distribution like this, okay? And we can type in what our n is. So we're shooting 10 free throws. That's how many attempts we have. And you can see that changing the size of n changes the number of possible outcomes. The probability of a success is 62%. Now we can get the distribution right here. Visually, we can see how likely each outcome is. And we have the probability table over here as well. So, going back to our homework, we see that it should match what's on your notes. Now we can ask some questions. So what's the probability that she makes exactly 5 free throws? You could calculate this by hand, or you can look at it over here. So 5 free throws, you can click on this and visually see it highlighted. That's 18.29%. Okay. You can write it as a decimal or as a percent. So it's actually the third most likely outcome, but it's still pretty small because there's a lot of possibilities. What's the probability of 9 or 10? Well, you can click on 9 and click on 10, and it'll add it up for you. You can add it up manually over here, or you can look down here. And again, let me switch so you can see the whole window. The probability that X is at least 9 and not more than 10, that's 9 or 10. You can see it shaded. If it's doing it correctly, see the shaded boxes. It adds it all up for you as 5.98%. And again, if we write this with the right notation, the probability that X is equal to 5, the probability that X is between 9 or 10, and you can write it as a percent if you want. Decimal is fine too. At most 2 means 0, 1, or 2. So again, you can click on that here, see that it's shaded correctly. You can also drag the triangles around. That's very unlikely, less than 1%, 0.86%. Or you could write it as a decimal. She's pretty good at her free throws. So the fact that she doesn't make, the chance of her not making very many, very unlikely. At least 7. Again, at this point, I think you can probably pause the video and go through these on your own. You can drag these around. You can click. You can use other buttons. I think dragging the triangles is usually pretty useful. The important thing is that when you're finding these probabilities, make sure that the shading is what we think. At least 7 free throws, you can see 7, 8, 9, and 10 are shaded. And it adds it up for you to 43.36%. That's basically all there is to it. Between 6 and 8, well, 6 and 8 looks like this. Inclusive means we're including 6 and 8. Because between 6 and 8 could mean 6, 7, and 8. Or it could mean just 7, depending on whether it's inclusive or exclusive. But it'll be 62.25%. Or you can write it like that. And this is our notation. Oh gosh. Pretend that that's an 8, please. Again, decimal or percent are both okay. Expected value and standard deviation, we could do it the old school way. We could do it with these shortcut formulas. Or GeoGebra tells us right here. So on average, we expect her to make, again, right, we expect her to make 6.2 free throws, plus or minus or like we expect it to be spread out by maybe 1.5 above or below. Another way to say this is we could say we expect her to make between 4.7 and 7.8 free throws, right? We expect most of the data to be within this range. We'll get really into that in the next section. One standard deviation above the mean, one standard deviation below the mean. Oh, it should be 7.7 if I can add correctly. Or you could even round, and I would take that as a good answer too. Between 5 and 8 free throws is another way of using this standard deviation. The important thing when you're doing this is to just use the right units. The mean is 6.2 free throws. The standard deviation is 1.5 free throws. Okay. And that's all you have to. That's the whole unit. It's tricky. There's a lot of tricky stuff here, but we break it down, we get some extra practice, and you'll be okay. The next video is just more examples. So go ahead and get started. Let me know if you have any questions, and have a good one.